You notice it the moment you look up tonight. A kind of quiet that feels intentional, as if something out there is waiting for you to pay attention. And maybe you should. Because 3 weeks ago, on January 12th, NASA released the closest images ever taken of the interstellar object, 3I Atlas, captured by the Mars Reconnaissance Orbiter as the object crossed within 43 million miles of the red planet. It's only the third interstellar visitor ever recorded, and already the strangest. Larger than Oumuamua, brighter than Borisov, and moving with a behavior no one can fully explain. But what you remember most isn't the image. It's the silence that followed. NASA held a 20-minute briefing. They showed a single frame. They answered a few routine questions. And then they ended it, without acknowledging the one detail that astronomers have been whispering about ever since. A detail you can see even in the blurred release photo if you know where to look. A faint plume, a soft ribbon of light. But instead of trailing behind Atlas, like every comet tail in the history of astronomy, this one was stretching forward, toward the direction of travel, toward the darkness ahead. That should be impossible. Sunlight pushes dust and gas away from the star, not toward it. Radiation pressure creates a tail that always points outward. That rule has been stable for billions of years. It's the reason Hale-Bopp looked the way it did. It's the reason Borisov behaved exactly as models predicted. It's the reason deep space comets flare in perfect arcs as they pass the sun. But when NASA showed the first close-range look at 3I Atlas, the brightest feature was not behind it. It was in front. And NASA didn't say a word about it. You sit with that thought for a moment, letting the quiet settle in around you. Because this isn't the kind of silence that comes from a lack of information. This feels like the silence that comes when information has been recognized, but not fully understood, or not yet ready to be explained. You wonder why a billion-dollar spacecraft in Mars orbit captured something that breaks a fundamental rule of comet physics. Yet the agency chose not to address it. You wonder why people like you can see the anomaly clearly, while the official statement rushed past it without even a pause. Avi Loeb didn't rush past it. When asked directly about the image, he leaned forward, studying the glow, the plume, the direction. And then he said something simple, something measured, something that refuses to leave your mind. This should not happen. Yet, it does. You imagine him in his office at Harvard, running through the same data you've seen summarized in headlines. Atlas, brightening by a factor of 400. Atlas, ejecting jets in multiple directions. Atlas, shedding a cloud rich in pure nickel, with almost no iron mixed in. Atlas, accelerating slightly near perihelion without any clear outgassing source. And now this, light where light shouldn't be, a feature leading the object instead of following it. It would be one thing if this were the first odd behavior, but it isn't. It's the latest in a chain, and chains have patterns. That's why tonight feels different. Not dramatic, just meaningful. Quiet, but heavy in its own way. Because you know you're looking at the sky during a moment that won't repeat. Atlas will never come this close again. The last time it passed through a solar system, humans didn't exist. The next time it does, if it ever does, your entire species will be gone. So you let your breath slow. You let the quiet deepen. And you follow the thread NASA didn't pull. Because there is a reason the glow is facing forward. There is a reason Avi Loeb has been running new calculations. There is a reason this object behaves like a traveler, carrying the memory of something that happened far beyond our reach. Something powerful enough to scar it, tilt it, brighten it, and send debris drifting ahead like a faint, lingering echo. Tonight, you're going to drift through that possibility. The one explanation that could make every Atlas anomaly fit into a single, coherent story. A story NASA didn't say out loud, but one you're going to hear. You remember the briefing almost as clearly as the image itself. It wasn't dramatic. It wasn't chaotic. It was something stranger than that. Quiet in a way that felt out of place. Almost like a meeting where everyone had agreed ahead of time which topics would not be mentioned. A single presenter, a short opening statement, a handful of carefully selected words, and the unmistakable sense that the agency was walking around something sitting right in the center of the room. NASA began with what sounded like reassurance, a reminder that interstellar objects are rare, that 3I Atlas had been tracked for months, and that everything observed so far was within the bounds of expected behavior. You remember that exact phrase, expected behavior. It was said with the kind of calm certainty that usually settles a crowd. But this time, it didn't. Not for you, and not for the astronomers watching from their offices, classrooms, and backyard telescopes. Then came the statement that stuck with everyone. There is nothing unusual to report at this time. You felt something shift the moment you heard it, because you had already seen the amateur-processed images circulating online. You had already noticed the soft plume facing forward. And NASA had seen far clearer versions than the public ever would. The Mars Reconnaissance Orbiter isn't a backyard lens. Its camera system has captured avalanches on Mars from orbit. It can see boulders the size of a dinner table from hundreds of miles up. If an amateur setup on Earth could reveal the glow, MRO would have seen it even more distinctly. And yet, the briefing moved on. Someone asked about the direction of the material. NASA didn't say, "There is no forward plume." They said, "We cannot comment on interpretations at this time." Someone asked if additional frames would be released. NASA replied, "We are evaluating the quality of the data." Someone asked about the 45-day delay between the capture and the publication. The answer was a single sentence about internal processing and scheduled maintenance. But everyone watching knew that the Mars Reconnaissance Orbiter had gone into safe mode for 11 days during that period. A shutdown, a pause, a silence of its own. And when the orbiter came back online, the first frames released were softer than expected, washed with motion blur, as if a thin layer of the truth had been smeared across the pixels. You wondered if it was intentional, or if it was just the universe playing tricks with timing and machinery. But the curiosity settled in your chest anyway. Because whatever the cause, one thing was clear. The cleanest details, those crisp boundaries that could have confirmed or dismissed the anomaly, weren't there. Blurred out, softened, lost in motion. And for the first time in years, amateur astrophotographers on Earth were producing clearer captures than NASA. You picture a man in Arizona or New Mexico with a sturdy mount and a good tracking system, processing images in his garage. The glow appears sharper on his screen than on the billion-dollar camera orbiting another planet. He uploads it online, and thousands see the plume you saw. Astronomers comment beneath the post, some cautious, some intrigued, some convinced this is just noise, but none of them call it nothing unusual. Not one. That's why tonight feels different. Because when a system as precise as MRO gives you blur, while a backyard telescope gives you structure, you start wondering what else you're not being shown. When the agency with the clearest view avoids the clearest anomaly, the silence becomes louder than the data. You can almost hear Avi Loeb's voice in the back of your mind. Absence of evidence is not evidence of absence. He says it often, but in this context it feels sharper, more relevant, especially now, when every odd feature of Atlas seems to stack onto the next like quiet stepping stones leading somewhere NASA hasn't acknowledged. And you can feel yourself leaning forward slightly, as if the mystery itself has a gravity of its own. This isn't the frustration of someone being misled. It's the curiosity of someone sensing a gap, a missing piece in a story that should be unfolding in the open. A feeling that something important wasn't said aloud in that room. Something simple, maybe. Something embarrassing for the models. Something that didn't fit the expected behavior the briefing leaned so heavily on. You breathe in slowly, letting the calm settle again, and realize the silence doesn't push you away. It pulls you deeper, because you're not here for sensational claims. You're here for the quiet truth hiding in the margins, the part of the story no one bothered to read aloud, the part you're about to hear. So what exactly is this object NASA barely described? You let the silence of the briefing drift to the edges of your thoughts as you turn your attention back toward the traveler itself. Because whatever NASA didn't say, whatever they avoided naming, the object they photographed is still out there, moving through the solar system tonight with a presence that feels almost cinematic in its strangeness. You picture it, drifting through the dark, not with the delicate fragility of a comet, but with the steady momentum of something older, heavier, and far more mysterious. Astronomers estimate that 3I Atlas is roughly the size of a small city, about the footprint of Boston, a frozen, tumbling mass on an interstellar trajectory, carrying the weight of distances your mind struggles to imagine. If Oumuamua was a wandering shard the size of a football field, Atlas is a megastructure by comparison, 1,000,000 times more massive. A body large enough to survive encounters that would tear smaller travelers apart. And somehow, it has carried itself across the void at nearly 60 kilometers per second, a speed so high that even the gravity of the sun can barely bend its path. You imagine that speed, 37 miles per second, fast enough to cross the continental United States in a minute, fast enough to leave the sun's domain entirely, its path barely altered after brushing past our star. Whatever its origin, it came from a place farther than your imagination comfortably stretches. A place without starlight for eons at a time. Perhaps a place where collisions happen in the dark, where fragments drift for millions of years without ever encountering another world. When astronomers say they don't know how far it has traveled, they mean that literally. There are no markers, no timestamps, no memory in its orbit you can decode. But the behavior it shows now, that's the part no one expected. Even before the NASA images, Atlas had already become an object that astronomers followed with equal amounts of excitement and confusion. Its brightness surged 400 times over the course of just a few weeks, as if some buried layer of volatile material had awakened. Its color shifted in ways that comets rarely do. Deep red to green, then settling into a soft blue that telescopes captured like a glowing ember cooling in reverse. These weren't cosmetic details. These were compositional clues, signals that the material inside Atlas is unlike anything normally carried by comets born in our own solar system. Then came the jets. You've seen images of comets shedding streams of gas like thin white hairs trailing behind them. But Atlas doesn't follow that pattern. Its jets flare from multiple angles, sometimes perpendicular to its direction of travel, as if the object is venting from fractures or cavities, not from a smooth surface warmed evenly by the sun. The result is a shape that doesn't behave like a nucleus releasing dust. It behaves like something reacting, shedding, opening, or shifting beneath the surface. And then there's the anti-tail, another rule broken quietly, almost politely. While a comet's tail stretches away from the sun, the anti-tail points back along its orbital path, usually created by large particles spreading out in a plane. But Atlas's anti-tail brightened at a distance where such a structure shouldn't have formed so clearly. Like everything else about this visitor, the details don't line up the way they should. Even its survival was unexpected. Astronomers watching its approach expected it to fragment as it passed close to the sun. Most long-period comets shed pieces or break entirely under that kind of heat and tidal stress. But Atlas emerged from perihelion intact, still glowing, still shedding, still accelerating in ways no one can fully account for. It came in like a question and left like an answer that doesn't quite match the problem. And yet the most improbable detail may have appeared before any of its behavior became known: its trajectory. Atlas entered the solar system exactly along the ecliptic plane, the thin, flat sheet where all the planets orbit, a 1 in 500 chance, like tossing a coin and having it land on its edge. Most interstellar objects approach from above or below the plane, crossing it only briefly. But Atlas slipped in along the very lane where Earth, Mars, Jupiter, and the rest of the planets reside. Avi Loeb looked at that alignment and said, "It came exactly along the plane of the planets, as if on a mission." And even though he meant it metaphorically, you understand the feeling behind those words, because nothing about this object moves like a careless wanderer. Nothing about it feels accidental. If chance is responsible, then chance has worked harder here than it usually does. You let your imagination go quiet for a moment, just feeling the scale of everything you've heard. A city-sized interstellar visitor, 1,000,000 times the mass of the first one ever found. Color shifts, jets, anti-tail, unexpected survival. And now, an orbit that threads the cosmic needle with an elegance that makes you inhale a little more slowly. No interstellar visitor behaved like this before. And yet, its strangest feature isn't its size. It's the glow. You've heard about comet tails for most of your life. Even if you never studied astronomy, you know the basic rule. A comet glows behind itself. The heat of the sun vaporizes ice and dust, and radiation pressure pushes that material outward, away from the star. It doesn't matter which direction the comet is traveling. It doesn't matter how fast it's moving. The physics are steady, predictable, almost comforting in their reliability. For as long as comets have existed, they have followed the same script, glowing in the sun's direction, trailing their luminous dust behind them like a signature written in light. But Atlas breaks the script. Not by a little, by a lot. When you look at the enhanced image, even through the blur and reduction NASA released, the brightest part of 3 Atlas isn't following behind the object. It's ahead of it, stretched out in the very direction it's traveling. A plume of light shaped like a faint spear point. A glow that shouldn't exist, a signature that pushes against everything you've learned about what light and dust should do in the presence of the sun. Comets always glow away from the sun. Atlas glows toward its destination, and that detail alone forces you to pause. Because it isn't just unusual, it's physically backward. It asks a question that nature usually answers with silence. What kind of object produces a plume in front of its motion instead of behind it? What kind of event leaves material leading the way instead of trailing it? What kind of traveler carries light like a lantern pointing into the darkness ahead? You let that thought settle, and for a moment the universe feels wider than it did a few minutes ago. Astronomers have tried to fit the anomaly into familiar categories. They've compared Atlas to Hale-Bopp, the grand comet of the 1990s, with its brilliant, sprawling double tails. They've compared it to Borisov, the first interstellar comet that behaved almost perfectly like the ones born in our own solar system. They've even compared it to Oumuamua, the object whose thin shape and unexpected acceleration stirred debates that still ripple through astrophysics today. But none of those comparisons survive long, because no known comet, not even the strangest one on record, has ever glowed in the direction of its travel. The laws that shape a comet's appearance simply do not allow it. Gravity can't do it. Radiation pressure can't do it. Outgassing can't do it. Rotation can't do it. If a comet were to glow forward under natural processes, it would have to break the relationship between the sun and its own dust. And that relationship isn't flexible. It's etched into the basic architecture of the solar system. The sun pushes, the comet trails. That's how it has always been. So, if this isn't a normal tale, what is it? You listen to the theories with the same calm curiosity you bring to a quiet night sky. Astronomers have offered a few possibilities, each one intriguing, none of them fully satisfying. One idea is that the glow might be a shock front, a thin region of gas compressed by the object moving through interplanetary material at extraordinary speed. At 60 kilometers per second, Atlas plows through dust grains and charged particles that could, in theory, pile up ahead of it like a bow wave. You imagine a ship pushing through water, the foam gathering at its prow. But when you picture it clearly, the analogy begins to break. Interplanetary space isn't an ocean. It isn't even a thin mist. It's closer to a vacuum than anything you will ever experience on Earth. There isn't enough material to create a shock front bright enough to resemble a plume of light. Not by a long shot. Another idea is that the glow might come from a debris cloud leading the object. Imagine shattered fragments or dust broken loose, not by the sun, but by some earlier impact. Instead of drifting behind Atlas, these pieces could have been launched ahead by momentum from a violent event that happened long before the object entered the solar system. A forward-moving cloud like that could reflect sunlight and appear as a plume. It's a strange idea, but at least it respects the laws of motion. Still, it raises the question, what could have struck something this large with enough force to scatter debris ahead of it? A third idea is that the plume could come from a hollowed cavity, an internal chamber exposed by a crack or fracture. If sunlight struck deep material inside the nucleus, it could erupt forward rather than backward. But that scenario requires the fracture to point precisely into the direction of travel and to remain stable as the object rotates. It's possible, but astronomers quietly admit it isn't likely. None of these explanations ignore physics, but none of them truly fit either. The glow isn't behaving like a natural consequence of motion. It's behaving like the residue of a story the solar system didn't witness. A story written somewhere between the stars. And that's where the curiosity sharpens, soft but undeniable. Because if this plume isn't a comet tail, if this plume isn't normal outgassing, if this plume isn't sunlight pushing dust backward, then the plume might not be a plume at all. It might be something else entirely. Something reflecting sunlight rather than emitting it. Something scattered, not streamed. Something left behind by an event that happened before Atlas ever crossed the boundary of our system. You hear Avi Loeb's voice again in the back of your mind. This should not happen. Yet, it does. And the more you sit with those words, the more they feel like a doorway. Not a conclusion, a beginning. Because sometimes the universe doesn't break its own rules. It simply shows you that something happened outside the small region of space where those rules feel familiar. Something that left a mark. Something that Atlas is carrying with it, like a memory etched into dust. Unless something happened before Atlas reached us. You let the forward-facing glow linger in your thoughts for a moment longer, as if studying it from across a quiet room. Then you shift gently toward the one idea that has held more weight than any other explanation. A possibility that isn't wild or sensational or even new. It's simply something astronomers rarely need to consider, because the spaces between stars are so empty that most travelers pass through them untouched. But rare and impossible are not the same thing. And in the mind of Avi Loeb, that small difference matters. To understand his idea, you have to picture the interstellar medium for what it truly is. Not a clean vacuum, not an endless stretch of nothing, but a thin desert of particles, dust grains, charged ions, small rocks drifting like forgotten seeds, spread across distances so vast that you could travel for 1,000 years before meeting anything larger than a pebble. Yet even in that emptiness, chance still works. And when an object is moving at 60 kilometers per second, even a collision with something the size of a baseball can be catastrophic. Loeb starts there, with the speed. Because velocity in space isn't just motion, it's energy. A tiny fragment the mass of a stone, hitting a city-sized object at interstellar velocity, releases the equivalent of high explosives, enough to crack open a surface, enough to carve out a hollow, enough to send debris scattering forward like sparks kicked ahead of a meteor. When you think about it that way, the idea becomes less dramatic and more elegant. Not a disaster, not a cosmic accident, just a single moment in a journey that may have lasted millions of years. A moment Atlas has carried with it all the way to your solar system. That single moment can explain more than most people realize. A collision, even a small one, can create a fracture, a deep, uneven break in the surface. And if sunlight penetrates that opening, the heat can escape not backward, but sideways, or even forward. That's how you get jets coming from unexpected angles. That's how you get gas streaming toward the sun instead of away from it. Not because the physics changed, but because the surface that normally shapes a comet's behavior is no longer intact. A broken object breathes differently, vents differently, glows differently. And in Atlas, every strange feature aligns with that possibility. You return to the glow, the plume that stretches toward the object's destination rather than its past. In a collision scenario, that glow doesn't need to be gas pushed against physics. It can be material thrown forward by the original impact, dust and fragments still drifting ahead along the object's path, reflecting sunlight like a faint cloud. The glow becomes a breadcrumb trail, pointing not to the sun, but to the event that left its mark. The more you consider it, the more the pieces fall together with a kind of quiet logic. The color shifts, a fractured interior releasing volatile layers that normally remain hidden. The multi-directional jets, gas escaping not from a smooth surface, but from irregular openings created by an impact. The anti-tail, large particles expelled in a plane shaped by the fracture rather than the sun. The survival at perihelion, a sign the core is stronger and denser than expected, possibly reinforced by metals or compacted rock exposed by the collision. Even the slight non-gravitational acceleration, the tiny push detected near the sun, fits elegantly into the idea. If debris is drifting ahead of Atlas, even loosely, the sunlight striking those pieces could create minute forces that pull the object in ways a standard comet model can't replicate. Not enough to be dramatic, just enough to be measurable. You think back to all the puzzling details from the earlier observations. How astronomers noticed that the jets didn't align cleanly with solar heating. How some of the brightest vents pointed toward the sun itself, as if the object were pushing material directly into the star's light. That used to break every rule. Then a collision was added to the picture, and suddenly the rule wasn't broken at all. It was simply being applied to a surface that no longer resembled a normal comet. Avi Loeb summed it up in a single line. If it collided, everything suddenly makes sense. You let those words settle, because they don't just explain one anomaly. They connect all of them, not with wild speculation, not with leaps of logic, but with the simplest mechanism nature uses to reshape the surfaces of worlds: impact. Interstellar collisions may be rare, but they're not mythical. They're part of the quiet physics that govern galaxies. Slow, sparse, and patient. And an object the size of a small city, drifting for millions of years, crossing unknown regions, passing through dust lanes and molecular clouds, has had plenty of time to meet something it shouldn't. You picture Atlas carrying that moment with it. The fracture, the debris, the asymmetry, the glow. All of it encoded into its motion, like a long-distance memory. And yet, as convincing as the collision scenario sounds, Loeb didn't stop there. Because in science, every answer opens a door to a new question. And just when astronomers began to settle into the comfort of a tidy explanation, another signal appeared. Something no comet should have produced. Something that deepened the mystery instead of resolving it. Something that made scientists look again, more carefully, more slowly, realizing there was still another layer hidden beneath the first. And then, a new signature appeared. One no comet should have. You've been following the collision idea long enough now that its logic feels steady beneath your feet. The glow, the jets, the strange behaviors. They all connect if you imagine Atlas carrying an old scar from somewhere in the interstellar dark. But then astronomers pointed their spectrographs toward the object, splitting its light into the chemical signatures hidden inside the glow. And what they found didn't just raise questions. It reset the entire conversation. Because the light streaming from Atlas revealed something almost no one expected to see. Not dust rich in iron, the usual fingerprint of comets. Not the typical blend of silicates and frozen gases, but nickel. Pure nickel, almost no iron at all. You pause with that for a moment, letting the strangeness sink in. Nickel and iron are like twins in natural cosmic materials. Whenever you find one, you almost always find the other. They form together in supernovae. They cool together inside planets. They weather together in asteroids. When comets shed dust, that dust almost always contains iron because comets are ancient leftovers from planetary formation, a blend of everything that swirled around young stars. But Atlas isn't behaving like a leftover. It's shedding nickel as if it has an interior rich in the metal, far richer than anything seen in comets from our own solar system. The spectral lines were sharp, unmistakable. This wasn't a blend, or a noisy reading, or a misaligned instrument. This was nickel announcing itself with clarity. You feel your curiosity sharpen again in that quiet, steady way. Because pure nickel in dust form means something dramatic happened to the material, something that separated nickel from its usual partners, something that heated, fractured, or refined it, something that changed the surface enough for sunlight to throw off a clean signal with almost no iron contamination at all. And that leads to three possibilities, each one surprising in its own way. The first is violent heating, the kind you get in the aftermath of extreme events. Temperatures high enough to strip away certain materials while leaving others behind. If Atlas passed through a region of intense radiation, or if part of it was flash heated during a collision, the iron could have sublimated or redistributed while nickel remained. But for that to happen, the event must have been extraordinary. Not a gentle warming, a furnace moment, a shock of energy in an environment where nature usually takes its time. The second possibility is an interstellar shock, a collision not with a single object, but with a region of compressed gas or high-energy particles. These shocks exist in the arms of galaxies, leftover waves from old supernovae or dense pockets of material drifting between stars. If Atlas struck something like that at interstellar speeds, the outer layers could have been stripped away, exposing metal-rich material underneath. Some models even suggest that nickel-heavy deposits can form inside large bodies under certain pressure gradients, meaning a shock could have cracked open a region we would never see otherwise. And then there's the third possibility, the one that draws the most attention, not because it's the most likely, but because it's the most mysterious. Some experts noted that the purity of the nickel and the lack of iron resembles the composition found in certain industrial alloys on Earth. No one claims Atlas is artificial. No one leaps to conclusions. But the resemblance is enough to make astronomers sit a little straighter. Enough to make a quiet pause fall across discussions. Enough to add a strange new color to the entire mystery. Avi Loeb's comment was simple, almost casual, but it carried weight. We only see this composition in industrial processes or in violent shocks. You repeat that in your mind for a moment, not because of the first possibility, but because of the or. Industrial processes or violent shocks, natural or engineered. Two vastly different doors to open. And the only one you follow tonight is the natural one. But the fact that both doors exist at all is enough to shift the tone of the entire story. Then comes the detail that ties everything back to the earlier anomaly. The nickel cloud isn't trailing behind Atlas like a normal comet tail. It's leading the object, settled into that same forward-facing plume that NASA avoided mentioning. A cloud of reflective particles drifting ahead, catching sunlight in a way that makes the glow brighter and sharper. Suddenly, the forward plume isn't just a visual curiosity. It's a chemical signature, a clue, a map. If Atlas experienced a collision, whether with a fragment, a shock wave, or a region of dense particles, that event could have cracked open a nickel-rich interior. Materials that were buried for millions of years could now be streaming outward along the fracture. And if the impact hurled material ahead of the object, the nickel dust would naturally form the glow in front. You realize how elegantly the pieces line up. A fracture explains the asymmetric jets. A debris cloud explains the glow. Nickel explains the unexpected spectral signature. And an old impact explains why parts of Atlas behave like they've been rearranged from the inside out. The surprise becomes wonder. The wonder becomes quiet fascination. And the fascination becomes a calm sense of discovery. As if the universe has turned a page you didn't know you were allowed to read. You sit with that feeling for a moment. Let it settle. Let it open the next question slowly, the way good mysteries do. Because chemical clues don't just tell you what an object is. Sometimes they point toward where it came from, or what it passed through, before it ever reached your skies. But this isn't the only echo from the past. For a moment, you let the nickel signature fade into the quiet, like a ripple settling back into still water. The mystery hasn't vanished, but it has changed shape, softened into something contemplative. And then another thread drifts into view. One pulled not from the object itself, but from the history of strange signals that echo through the sky. A memory of a moment when the universe whispered something unexpected into one of our instruments, long before anyone on Earth had ever heard the name 3 Atlas. It happened in 1977. Late summer. A mild night in Ohio. The Big Ear radio telescope was sweeping across the sky, collecting data on hydrogen emissions from deep space. Nothing dramatic, just the slow, steady monitoring of cosmic background noise. And then, for 72 seconds, something appeared. A narrowband radio signal, strong and clean, coming from a direction that didn't match any known satellite, star, or planet. A spike 20 to 30 times higher than the surrounding noise. Tight, precise, and unmistakably artificial in shape. The astronomer on shift, Jerry Eamon, circled the signal on the printout and wrote a single word next to it. Wow! The name stuck. The mystery stuck. And for nearly half a century, the wow signal remained one of the most tantalizing hints of something unusual beyond our solar system. Never repeated, never explained, never forgotten. You feel the nostalgia of that story settle around you like warm dust. Anyone who has followed astronomy for long enough remembers where they were the first time they heard about it. A moment when the universe seemed to come a little closer, just for a breath. Now, decades later, something unexpected has tied that summer night to the interstellar visitor drifting through your sky. Because when astronomers plotted the region Atlas is currently moving toward, they noticed something quietly astonishing. The object is approaching a patch of sky just 9 degrees from the direction the wow signal came from. Not the same point, not the same star, but close enough that astronomers raised their eyebrows, leaned back in their chairs, and stared just a little longer at the trajectory lines. Same sky, 48 years apart. You don't jump to conclusions. That's not what this story is about. And even Avi Loeb is careful here. When asked about the alignment, he said only, "It's close enough to make you raise an eyebrow." Not confirmation, not speculation, just an acknowledgement of the strangeness, because the possibilities remain open and gentle. The first is simple: coincidence. The sky is large, but not infinite. Objects pass through similar regions all the time. Perhaps Atlas's path and the wow signal's origin simply overlap by accident. Two unrelated events sharing a thin corridor of sky. Astronomers understand coincidence more deeply than most people. Random patterns appear everywhere when you have enough time and enough stars. The second possibility is that both events originated from the same broad region of the galaxy. Maybe Atlas passed near the place the wow signal came from, not as a messenger or a carrier, but as a wanderer from a region rich in activity. The Milky Way's arms contain pockets of star formation, supernova remnants, and drifting clouds of debris. Perhaps Atlas's journey and the wow signal's transmission simply intersected in the same general neighborhood. The third possibility is the softest, the one you entertain carefully, like holding a fragile object in your hands. Maybe the glow in front of Atlas and the wow signal are simply echoes from the same interstellar route. Not connected, not intentional, but shaped by the same region of space. A space where collisions happen more often. A space where dust is denser. A space where the past leaves traces in unexpected ways. None of these ideas claim anything extraordinary. None of them rewrite physics. They simply place two strange events into a common frame without pretending that frame has an answer written on it. And somehow, that makes the connection feel more powerful. You let yourself drift with it for a moment, not chasing certainty, just acknowledging the wonder that comes from seeing two distant points in history lean slightly toward one another. Atlas, moving through a region tied to a mystery from 1977, doesn't demand any conclusions. It doesn't require that one event explain the other. It simply asks you to listen with the same quiet curiosity that astronomers felt when that 72-second signal first appeared. The sky is old. Its memories are long. And sometimes the echoes take decades to align. You exhale gently, allowing the sense of drifting to return. The puzzle pieces aren't forming a picture yet, but they're forming a shape. A gentle, suggestive outline. The kind that keeps you leaning forward, not out of urgency, but out of the simple desire to understand the quiet things the universe has been hinting at in the dark. But not all mysteries come from the past. Some are missed in the present. You let the alignment with the wow signal fade gently into the background, like a constellation slipping behind a thin layer of cloud. Because the next chapter of this story isn't about what the universe offered in the past, but what it offered recently, and what slipped quietly through our fingers. It's a softer kind of mystery, not built on anomalies or strange physics, but on timing, on the delicate choreography of planets and objects moving through space, each one following its own path, unaware of how close they come to giving us answers we may never get again. Astronomers realize this too late to do anything about it, but not too late to feel it. A brief window of possibility, almost perfect, came and went while Atlas was still far from the sun. A moment when Earth, its rotation, and its distance from the object lined up in a way that made radar mapping possible. Not just imaging, mapping. If we had been 6 months earlier in our orbit, one season ahead, Earth-based radar could have illuminated Atlas with enough power and clarity to build a full 3D reconstruction of its shape. Every contour, every ridge, every fracture, every cavity holding that nickel-rich material. We could have seen whether it was elongated like Oumuamua, or compact like Borisov, or something entirely different. Something that doesn't fit the library of natural shapes carved by the slow hands of solar system history. Instead, when Atlas entered radar range, Earth was tilted just slightly wrong. A shift of geometry, a turn of fate. Nothing dramatic, just the quiet indifference of celestial mechanics. The object was there. Our instruments were ready, but the angles were off. The beam couldn't lock. The echo wouldn't return. And you're left with a question that sits gently in your chest. How close were we? Close enough that scientists felt a real ache when they ran the numbers. Close enough that you can almost imagine the radar image that could have existed. A lattice of data points mapping the surface of a visitor from another star in exquisite detail. Close enough that a single shift in Earth's position, just a tilt, just a season, would have given us one of the most valuable astronomical data sets of the decade. You imagine the model that could have been built, a full 3D rotation, sunlight simulated across its surface, a clear look at the fractures, the jets, the mineral veins exposed by whatever event shaped its past. We could have compared its structure to every known comet, asteroid, and interstellar object. We could have measured its symmetry. We could have identified the exact angles of the vents that produce its contradictory jets. We could have seen the cavity that may or may not be responsible for the nickel signature. And maybe most importantly, we could have known whether Atlas resembles anything in our own solar system or nothing at all. But we were a season too late. There's no anger in that, only a quiet melancholy. Earth is always moving. Atlas is always moving. The universe never stops long enough to match two paths perfectly. Every rare visitor arrives on its own timeline, not ours. And sometimes the most meaningful opportunities slip away, not because we failed, but because the cosmos keeps its own schedule. You breathe out slowly, letting that idea settle. There's something grounding about it, something that reminds you of the Carl Sagan line that people quote when they feel small in a meaningful way. We are star stuff pondering the stars. You think about that tonight. How your species, built from the same metals and minerals drifting through space, reached out to map another traveler, made of the same ancient dust, and just missed. Not by distance, not by technology, just by timing. And yet, there's a gentleness to the loss, because even though we missed the radar window, we didn't miss the visitor itself. We still have the light, the spectra, the anomalies, the glow, the path, the way it threads the ecliptic like a needle, the way it carries a story older than anything orbiting our sun. And more than that, there's still more we can learn. New data is coming in every day. New observations from Earth and Mars. New spectral readings. New questions connecting to old ones. The universe isn't done revealing pieces of Atlas's past. It's only reminding you that some chapters require patience to unfold. You let the quiet deepen again. The video isn't racing toward answers. It's drifting through possibilities, the way Atlas drifts through the solar system, slowly, steadily, leaving traces of itself in every direction. And now, after everything you've heard so far, another question begins to rise. A more grounded one, a more familiar one. So what if Atlas is natural after all? You take a slow breath, letting the ache of the missed opportunity soften into something gentler. Because even though so much about Atlas feels strange, its glow, its jets, its nickel, its path, there's still room to hold the possibility that nature herself is responsible. Space is full of oddities that don't fit the categories we try to place them in. The universe doesn't owe us familiarity. Sometimes it offers objects that look engineered, only because we haven't yet explored enough of its creative, chaotic, unpredictable designs. So you let yourself imagine the natural scenarios first, not to dismiss the mysteries, but to balance them. To remember that the cosmos has spent billions of years surprising astronomers with behaviors that once seemed impossible. Atlas may be one more entry on that long list of cosmic strangeness. Start with the idea of an exotic nucleus, a comet whose internal structure simply isn't like the ones that form around our sun. Our solar system's comets were shaped in the cold outskirts of the protoplanetary disk, carrying familiar mixtures of dust, rock, ices, and metals. But Atlas comes from another star system, maybe one with a different chemical fingerprint, a different temperature profile, a different birth environment entirely. If its nucleus is layered with minerals that don't exist in our comets, or if its interior cooled in ways we've never observed, that could explain why it brightens the way it does, why the colors shift so dramatically, why metals like nickel appear so strongly in its spectra. An exotic nucleus doesn't break any rules, it just broadens them. Then there's the possibility of a rotation axis tilt. Most comets spin with their poles oriented at comfortable angles relative to the sun. But if Atlas rotates with an extreme tilt, say 90 degrees, sunlight might strike interior pockets or vents in unusual ways. That could send jets shooting off in multiple directions, It could make the anti-tail flare brighter than usual. It could even explain why some jets seem to push toward the sun instead of away from it. Not because they're defying physics, but because the surface is simply rotating unpredictably, exposing pockets at odd angles. Next comes the idea of volatile layers, deep deposits of material that react dramatically once sunlight reaches them. If Atlas formed in an extremely cold region of another star system, its ices might include compounds that vaporize rapidly when warmed. Instead of melting slowly, they could erupt in bursts. That could account for sudden brightening. It could explain the 400x increase in luminosity. It might even explain the sharp color transitions, red to green to blue, each one representing a different volatile layer vaporizing in sequence. And then there's thermal cracking. As comets heat, their crusts expand and contract. On a normal comet, small cracks open and close with little consequence. But on a large, dense object like Atlas, thermal stress could split open deeper chambers. When that happens, sunlight doesn't just warm the surface. It reaches internal reservoirs that have been sealed for millions of years. A sudden vent could send dust outward in unpredictable patterns. A deeper fracture could rotate into sunlight, releasing jets that appear to aim directly toward the star. When you hold all these possibilities together, exotic nucleus, tilted rotation, volatile layers, thermal cracking, you can almost imagine a natural explanation that fits many of Atlas's behaviors. Not all of them, but many. Enough to soften the edges of the mystery, enough to steady your mind as you drift through the possibilities. And in a way, that's comforting, because even in their natural forms, cosmic anomalies can be beautiful. You think about the comets that once baffled astronomers, Hale-Bopp with its enormous twin tails, Enki with its mysterious flares, Borisov with its unusual fragmentation, even Oumuamua, whose non-gravitational acceleration still sparks debate. Nature can be bizarre too. It doesn't need help to be surprising. And in that realization, you feel something settle, a quiet humility, a reminder that your understanding of the universe is still so young, so small, compared to the ancient processes shaping interstellar travelers. Science progresses not by dismissing anomalies, but by absorbing them, testing them, and letting the data push us forward. Still, as grounded as these natural scenarios sound, they don't close the case. They don't erase the glow that leads the object. They don't explain the purity of the nickel. They don't account for the symmetry of the ecliptic approach. They don't resolve the multi-directional jets or the gentle acceleration that appears unrelated to solar heating. Natural explanations bring relief, but they don't bring closure. You feel that lingering curiosity again. Not urgent, not alarming, just a soft tug. The sense that something about Atlas doesn't settle neatly into the categories we've built for comets. You can almost hear the unanswered question forming beneath the data, waiting to drift into the next part of the story. Because even if Atlas is natural, what if it isn't alone? And yet, what if Atlas isn't alone? You let the natural explanations settle softly in your mind, like dust drifting into place. They bring a sense of clarity, a kind of gentle grounding after the mysteries you've passed through. Yet something still lingers. Not fear, not urgency, just a subtle curiosity, like a faint breeze stirring the edge of a curtain. Because even if every part of Atlas's behavior could be explained by collisions, fractures, heating, or exotic chemistry, there remains one question astronomers keep returning to. If something struck Atlas long ago, carving open its interior and scattering nickel-rich dust into its path, could fragments of that impact still be out there? The idea drifts into your thoughts quietly, almost politely. Atlas is large enough that it could have survived a collision that shattered smaller bodies. When a massive object is hit at interstellar speeds, not everything breaks or vaporizes. Some pieces shear off. Some are thrown forward. Some spin away in broad arcs. And some follow behind like faint companions, invisible until the right light hits them. Astronomers have studied the asymmetry of Atlas's jets, tracing the faint angles of dust release, mapping which sides flare and which stay dormant. And the pattern, while subtle, has suggested something intriguing. The jets aren't distributed evenly. Some seem to come from regions that look carved or hollowed. Others align with surfaces that appear to be missing material. Small irregularities in light curves hint at shadows or dimming patterns that don't match a smooth, intact object. Nothing definitive. Nothing that stands up as proof, but enough to make a certain group of astronomers wonder whether Atlas might be traveling with debris not yet visible, or with fragments that moved ahead after the original collision. The question becomes gentle but compelling. Could pieces of Atlas be leading it, hidden in the same plume of light that faces forward? That possibility, quiet, understated, was enough for researchers to ask NASA and the Mars orbiters to check their frames again. Not just for Atlas itself, but for anything small drifting nearby. The sort of fragments that wouldn't show up in early image releases, especially if the processing softened or blurred fine details. NASA hasn't reported anything. No fragments, no companions, nothing that stands apart from background dust. But they're watching, and that matters. Because even though the absence of evidence isn't evidence of absence, the search itself tells you that the idea isn't far-fetched. A collision strong enough to crack open a nickel-rich cavity could easily scatter debris across a wide region. Some pieces might have been redirected by sunlight. Some might have drifted ahead of the object, moving with just enough difference in velocity that they've become a faint, forward trace of the event. You imagine those pieces, small, cold, ancient, sailing through space ahead of the parent body like quiet outriders. Not dangerous, not dramatic, just geological memories drifting on their own paths. Space is full of such remnants, each one a postcard from a moment of violence softened by time. Avi Loeb spoke about this lightly, the way he does when he's careful not to overstate. If anything split off, we might still detect it, he said. It wasn't a claim. It wasn't a warning. It was simply a reminder that fragments don't disappear just because they're difficult to see. They drift. They scatter. They wait for the right angle of light. You feel a small rise in the tension. Not sharp, not unsettling, but subtle, like the faint hum you notice when electrical lines vibrate in cold weather. It isn't fear. It's awareness. The knowledge that even now, telescopes are pointed at the regions near Atlas's path, checking for tiny flashes, brief dimmings, or the thin streaks that betray small bodies moving in formation. And yet, With all that careful watching, there's still no evidence of a companion piece. No shard, no co-traveler, no object moving in perfect sync. The uncertainty becomes its own kind of answer, soft, incomplete, and strangely calming. Because sometimes the absence of a finding isn't a disappointment. It simply means the story still has room to unfold. You breathe in slowly, sensing how the tension rises and softens. There's something soothing in knowing that the universe doesn't reveal everything at once, that some mysteries remain gentle, unthreatening, suspended in the quiet space between what we know and what we hope to learn. Atlas may be alone, or it may not be. The sky will tell us over time. For now, you sit with the possibility, fragments drifting unseen, shadows that come and go, dust carrying the memory of an ancient collision, curiosity without fear, mystery without danger. The kind of tension that feels almost like a heartbeat, steady, subtle, guiding you toward the next question. Because beyond all theories, collision or natural, fractured or exotic, another thought rises. One that brings you back from the mechanics of space and the behavior of dust to something more personal. What does Atlas mean for us? You've followed Atlas across millions of miles, through collisions and clues, through missing windows and spectral surprises, through questions that stretch from 1977 all the way to tonight. And now, as the object drifts farther from the sun and the data softens into the quiet hum of long-distance observation, something shifts inside you. The tension dissolves. The scientific curiosity slowly melts into reflection. And you're left with a deeper question, not about Atlas itself, but about what stories like this mean for you, for all of us, living our short lives beneath an ancient sky. Because somewhere in this long trail of light and mystery, the universe has been teaching you something. Not loudly, not urgently, but with the same gentle patience that shaped the dust around newborn stars. Atlas reminds you that curiosity is a kind of compass, pointing you toward what you don't yet understand. You didn't come to this story expecting certainty. You came to be reminded of something older and quieter, that a human life becomes larger when you allow yourself to wonder. That mystery isn't a threat, it's a doorway. The more you follow that doorway, the more humble you become. Humility isn't smallness, it isn't defeat. It's the realization that the universe is vast, and that you, somehow, are woven into it. Atlas is a visitor from somewhere you will never see with your own eyes. A traveler older than your species. A piece of frozen time drifting through the galaxy, carrying a story that began before the Earth had oceans. And yet here you are, tracking it through the night with instruments built by human hands, decoding its glow, listening for clues, letting its journey shape your imagination. There's something beautiful in that, something that makes you feel both grounded and lifted. You think back to the anomalies, the nickel, the glow, the odd approach along the ecliptic. Each detail sparked curiosity. Each clue invited you deeper. And in the process, something subtle happened. You stopped trying to solve Atlas and started listening to it. Because that's what the universe asks of you. To listen, to wonder, to let the unknown expand the edges of your world. Avi Loeb once said, "Curiosity is our greatest survival tool, not because it keeps you safe, but because it keeps you connected to knowledge, to possibility, to the sense that life is bigger than work and routines, and the heaviness that clings to a long day." Curiosity lifts you out of yourself, even if only for a moment, and lets you breathe from a higher vantage point. Atlas becomes a reminder that you are small, but not insignificant. You live on a pale planet orbiting an ordinary star in an ordinary arm of an ordinary galaxy. Yet you are capable of paying attention to a fragment from another sun, watching it glow, watching it change, watching it brush past Mars and whisper past Earth. Your species doesn't just survive. It looks up. It asks questions. It traces the path of a traveler from the dark and tries gently to understand. And there is meaning in that, deep meaning, the kind that settles in your chest and softens the edges of your thoughts. Not knowing everything is not a flaw. It's an invitation. The mystery of Atlas doesn't demand an answer. It invites you to rest inside the space where questions live, to realize that uncertainty can be peaceful, that the unknown can be a kind of lullaby, that the universe is most beautiful when it refuses to explain itself too quickly. So you lean into that softness. You let the vastness feel comfortable instead of overwhelming. You let the quiet parts of yourself rise to meet the quiet between the stars. Because in the end, what Atlas means for you is simple. It's a reminder that wonder still exists, that the universe is still full of firsts, that even in a world saturated with information, there are still secrets drifting toward the sun, still visitors crossing the dark, still stories that begin long before you're born and continue long after you're gone. You breathe out slowly, the way you do when the day finally loosens its grip. You feel the night open just a little wider, and you sense that the story is ready to fade gently into calm, preparing you for rest. And now, let the universe quiet down around you. You've traveled far tonight, through collisions and spectra, through mysteries and missed chances, through questions older than the earth, and possibilities gentle enough to hold in your hands. And now, as the story begins to dim like a lantern at the end of a long path, something inside you softens. You can feel the shift. The weight of the day loosens. The noise of the world eases back, and the universe settles into its quiet rhythm. Out there, far beyond the curve of your horizon, Atlas is drifting into darkness again. The glow that once puzzled astronomers is fading now, softening into a thin haze that trails behind it like a memory dissolving into space. The plume that once pointed forward is losing its brightness as the sun retreats behind it. Dust settles. Jets quiet. The strange blue and green flashes that once marked its rotation slow to the faintest flicker, barely visible against the deep black. The solar wind brushes gently past its surface, no longer a force, just a whisper. A thin, steady breath, carrying charged particles outward from the sun, touching the sides of the visitor as it moves farther into the cold. The wind doesn't push. It doesn't sculpt. It simply sings, a soft hum across a surface that has already told its story. You picture it drifting now, a dark silhouette against a field of distant stars, turning slowly, almost gracefully, carried by nothing but momentum. No destination, no intention, just a quiet continuation of a journey that began before your ancestors walked the earth, a journey that will continue long after this century, this era, this moment has passed. And as Atlas moves outward, the lights pointed toward it begin to fade too. NASA's instruments switch to low cadence. The Mars orbiters shift their cameras toward new tasks. The telescopes that once tracked every change now slow their observations, saving their attention for the next arrival, the next anomaly, the next whisper from the dark. Their glow, those images, those frames, those graphs, softens with the night as well. The hum of activity settles, the excitement quiets, the rush of discovery rests, and you find yourself resting with it. Your body settles deeper. Your breathing slows. The world around you becomes a dim, gentle cradle. You're no longer following a traveler across millions of miles. You're simply lying here, in your own sky, in your own night, letting the calm expand around you like a warm blanket. The universe hums softly now, not a sound you hear with your ears, but one you feel, like a vibration beneath your thoughts, a reminder that the cosmos is always moving, always breathing, always holding you within something ancient and enormous and steady. You're safe here. You've always been safe here, even when mysteries drift close, even when questions rise, even when the unknown brushes the edge of what you understand. Because not knowing isn't a threat. It's an invitation, a gentle one, a quiet one. And tonight, that invitation leads not to more questions, but to rest, to stillness, to the kind of peace that comes when you realize the universe isn't demanding anything from you. It's simply offering you space. You imagine Atlas one last time. Small now, dim, carrying its secrets into the long dark that waits beyond the sun's reach. It drifts. You breathe, both of you moving toward calm. The stars hang steady in their places. The night wraps around you like soft fabric. Your thoughts loosen, then drift, then soften into something gentle and warm. There's a feeling here, subtle but deep. A feeling that even in a universe filled with ancient storms, collapsing stars, and interstellar travelers, tonight is quiet. Tonight is safe. Tonight is yours to rest. Whatever waits in the dark, whatever new visitor crosses the solar wind, whatever new glow appears in the sky, whatever signal whispers through the quiet, can wait. The universe has been here for billions of years. It will be here when you wake. For now, just breathe. Let the darkness feel calm. Let the quiet expand. Let yourself sink gently into the space between thoughts. Good night, traveler.